Hello everyone. Welcome back to the online lecture series of fluid mechanics. We are in the second module, that is fluid statics, and we'll discuss about pressure measurement devices today. Pressure is a derived property. It is the force per unit area as related to the fluid molecular bombardment of a surface. Thus, most pressure measurement instruments only infer the pressure by calibration with a primary device such as a deadweight piston tester. There are many such instruments for both a static fluid and a moving stream, and these instruments may be grouped into the following 5 categories based on their principle of working. Gravity-based instruments, which includes barometers, which measure atmospheric pressure, manometers and deadweight piston. Elastic deformation-based instruments, Borden tubes, which can be made of metal or quartz, diaphragms, bellows, strain gauge and optical beam displacement. Gas behavior, gas compression, like the McLeod gauge, thermal conductance, such as the Pirani gauge, molecular impact, like the Knudsen gauge, ionization, thermal conductivity, and air piston. Alright, let's dive into electric output-based instruments. These are fascinating tools that convert physical quantities into measurable electrical signals. We have several types to explore. First, there's the resistance-based instrument, like the Bridgman wire gauge. This device measures strain by detecting changes in electrical resistance. Next, we have the diffused strain gauge. It's quite similar but uses a different method to measure strain, providing high precision. Then, there's the capacitative gauge. It works by measuring changes in capacitance, which can be incredibly useful for detecting small displacements. Let's not forget the piezoelectric instruments. These convert mechanical stress into an electric charge, making them perfect for dynamic measurements. We also have potentiometric devices. They measure displacement by varying the position of a contact along a resistive element. Magnetic inductance instruments are another type. They measure changes in inductance caused by the movement of a magnetic core. Similarly, magnetic reluctance instruments detect changes in magnetic reluctance due to movement, offering another way to measure displacement. Linear variable differential transformers, or LVDTs, are quite sophisticated. They measure linear displacement with high accuracy using electromagnetic induction. Lastly, we have resonant frequency instruments. These measure changes in frequency caused by physical changes, providing very precise measurements. So, as you can see, electric output-based instruments offer a wide range of methods to measure different physical quantities with great accuracy. Luminescent coatings for surface pressures. The gas behavior gauges are mostly special-purpose instruments used for certain scientific instruments. The deadweight tester is the instrument used most often for calibration. A barometer measures the local absolute atmospheric pressure. The height of the mercury column is proportional to the atmospheric pressure. A modern portable barometer with digital readout uses the resonating silicon element. The manometer is a simple and inexpensive hydrostatic principle device with no moving parts except the liquid column itself. They are further classified as simple U-tube manometers, single-column manometers, single-column inclined manometers, micromanometers, U-tube differential manometers, and inverted U-tube differential manometers. The world of instrumentations is moving quickly towards digital readings. The electric output sensors are extremely important in engineering because data can be stored on computers and easily manipulated, plotted, and analyzed.